Hello everyone. I'm recording this small video for this solution for MidSem question. Starting with question number 1. Most of you have done this question correctly. So here the question is the concept of human can be applied on replacement policy like DIP also instead of LRU. So there may be two questions. You can say yes or maybe. Both are correct. Because why maybe? Because the stack behavior that LRU maintain, that policy may not maintain in DIP, because the DIP is a combination of BIP and LRU, right? So if you have written that it is not possible, then also correct. And if you say that may possible, may not possible, and you give the explanation, both I have considered correct. But if you say just say that no, it is completely possible to apply human on DIP, then that is not correct. Okay, so two possibility here. One, not possible, I have considered this as correct. Two, may be possible. Okay, so that also I have considered as correct, but both with explanation. But if you say that yes, it is possible, then I didn't consider that is correct. So very straightforward. So now we go to question number 2. In question number 2, here you have to maintain counters, because if you want to maintain LRU policy and you maintain the partition, then you maintain some counter, or you have to count that at present how many blocks present for application 1 and how many blocks present for application 2, and you have to compare this. So based on this you have to write the algorithm. Okay, so those who have not used counter, I have not given you full marks. And part B is nothing, because the algorithm that you will explain in part A, same algorithm will be applied in part B. So just need to write a 2-3 line explanation in part B. So most of you have done it correctly, but those who have not mentioned about counters and used some other techniques here, I have deducted your marks. For 3, again it's a conceptual question. So if I go for question 3 part A here, then the question is if you apply these utilization techniques VUA, CMP, SVR or Zcash in SRAM as well as in STTRAM, so do you think the result will vary? So let us just consider about VUA. So if you implement VUA on SRAM and if you implement a VUA on STTRAM, do you think any difference? So you have to answer in this direction. Many of you are misguided and try to answer different other things. No, it is not the thing. The exact question is, if you implement VUA on SRAM LLC and if you implement VUA on STTRAM LLC, they will behave similarly or they will behave differently. Obviously they will behave differently, because even if you don't implement VUA, if it is a simple cache also, one is with SRAM, another is with STTRAM. STTRAM will not behave as SRAM, right? We know it from density paper. So this is the first point, but let us ignore that point. Some of you have written this point also, but let us ignore this point. This point can be ignored. So ignoring this point, do you think there will be any additional degradation here, any additional problem if you implement VUA in SRAM LLC, or if there is any additional problem if you implement VUA in STTRAM? Yes, there will be some additional problem, because number of writes in VUA, there will be some additional number of writes. You cannot say that there will be no additional writes, because of this forward and backward pointer, there will be some number of extra writes, and those may create problem, but the degradation will be less in VUA. Now if we go with CMP SVR, then if you implement CMP SVR on STTRAM, then obviously there will be some extra writes. Why some extra write? Because in SVM, if there is an indirect hit, in SVR if there is an indirect hit, then we migrate the blocks, right? So these migration means some extra writes. So obviously there will be some additional degradation because of these writes if we go with STTRAM, because write is expensive in STTRAM. Now if you go to Zcash, then Zcash there will be more number of writes, because you know for one replacement we have to swap multiple blocks among different sets, right? So those swap means multiple extra writes, and write is expensive in STTLC. So the answer of part A is all three VUA, CMP, SVR and Zcash have additional performance degradation because of extra writes, but it is less in VUA, medium in CMP SPR and high in Zcash. And obviously the answer of part B will be Zcash, because in Zcash has more number of writes. Okay, question number 4, no need to explain here. This is just a difference and most of you have done it correctly. Question number 5, do you think the policy of these two technique will be implement will be work on Hawkeye? So yes, the answer is yes, they will also work on Hawkeye, but there may be some performance degradation. But the question is, it is possible that do you think this policy will work? Yes, this policy will work in Hawkeye. Okay. So limitation. The second question is important. In limitation, some of you have written different things, but the main limitation is inter-set variation, because these techniques are only considering intra-set, right? Within the set they maintain the variation, but what about if the variation is in intra-set, means in one set it is uniformly rights are uniformly distributed, in another set rights are not uniformly distributed. So that point is not cannot be handled by these techniques. So this is the main answer here, the inter-set right variation, but some of you have missed it. So those who missed this important limitation, I have deducted some mark for you. Coming to question number 6, this is a very simple question, and again I removed this question and I given 5 marks to all of those who have attempted it directly without verifying it, because there was some confusion in the question. Okay, so in first part is very straightforward. The answer is 200 nanosecond. You can check those who have written 216 208. I have deducted mark for that, because it is very straightforward answer, 200 nanosecond. So I have deducted some mark for wrong answer here. Okay. Question number 7, very straightforward. In question number 7, this is a security related question. Here the answer is, you just need to run a threshing trace. If you are run a threshing trace from a particular core and count the number of misses. If you read the question, I have already explained how to detect a miss, how to detect a hit based on the time. So simply run a threshing application. If you are getting more misses, obviously it is a LRU replacement policy is going on, because LRU cannot handle thresh, but thresh can be partially handled by BIP. So the underlying replacement policy, if it is BIP, then if you run a thresh application, there will be some hits. So based on this, attacker can find out that if underlying replacement policy is LRU or BIP. Very straightforward answer. And again, question number 8, I think 90% of you done it correctly. So just need to write some step for get XA. First, there will be request here, and then there will be 2 invalidations sent from to core 2 and core 3. Once the acknowledgement received, then you will grant the permission to core 1. Very straightforward. If you go to answer B again, for upgrade C, there will be request coming to LLC, but C is now shared, so there will be invalidation request sent. One that acknowledgement received, then upgradation request will be given to C3. Similarly, get SE and is also simple, but here in D, the important point is the M is not in LLC. So when get request will come to LLC, then we'll also send a request to main memory, and from main memory the block will come here, and then we have to replace some block here, and then we have to place it. So those who have not written all these things, some deduction will be there. So what are the marking scheme here? 3 3 2 2. So if you have done some mistakes in any of these points, then your marks are deducted. For example, in D, if you have not written that there is a miss and we are going to main memory, then 1 mark is deducted. Okay, so I hope this this small video is clear to I'm giving enough hints to clear all the answers. If you face any issue to understand any answer, then you can ask me tomorrow. Okay, I'm stopping this video here. Thank you for watching.